Here's another problem from Chapter 9, Section 6, and it's a interesting problem. It says, how long must a wire be to reach from the top of a 17-meter telephone pole to a point on the ground that's 10 meters from the base of the pole? Okay, so we got how long must a wire be? And let me make some notes over here. So we got a 17-meter pole, and the wire is stretched out to some point 10 meters out. Okay, so I'll just make a couple of notes here. Well, let's look at this one together. This is pretty straightforward when you see the relationships that are involved. So I did a kind of a general diagram here of a right triangle. Right triangle. Now this is an important idea, that this stuff's only going to work the way they're doing it if you have a right triangle. And what is a right triangle? It's a triangle that has a 90-degree angle here. Okay. Now, the sides or legs for this thing to work are given distinct labels. And I call this one the A side, this one's the B side, and this one is the C side, And this is also referred to as the hypotenuse in a right triangle. So now, the side opposite, does that kind of sound like hypotenuse? Think about that. The side opposite the right angle, the side opposite the right angle, the side opposite the right angle is the hypotenuse, and it's also the longest side in the triangle. Now, this is just referred to as a leg of the triangle, a leg of the triangle. Now, about 3,000 years ago, it was discovered, and the school of mathematics of Pythagoras was given credit for this, and it's called the Pythagorean Theorem. And they determined that, interestingly enough, in any right triangle, that if you take the measurement of this leg and square it, the measurement of this leg and square it, that number added together is equal to this side squared. Okay, so that's pretty easy, isn't it? So look, this problem here I said, oh, look, I've got 3 squared plus 4 squared would equal 5 squared. Does that work? 3 squared, 9. 4 squared, 16. 5 squared, 25. See how that's working? Now, they always work out as neatly. And what they wanted us to do in this particular problem is they wanted us to envision this right triangle setup. Except what they had that problem in mind was they had different numbers. Okay, and so what did they have? Well, they said that this was the pole, and it was 17 meters. And they said that this was the wire running out from the base of the pole. This is the wire running out from the base of the pole, and it was 10 meters. And they wanted to know how long is the wire? What? Okay, so in other words, this is the pole, 19 meters high. They have a guy wire that is on the ground 10 meters out the base of the pole. And they're assuming that the pole is straight up and down, so it forms a right angle. So the question is, how long a piece of wire do they need to run from here to here? Okay, so it's just a simple Pythagorean theorem problem. You ready? A squared plus B squared, C squared. Or what's A? 17 squared. What's B? 10 squared equals C squared. All right, so thankfully we do have calculators, so let's use it. You ready? So 17 squared is 289. And we can do this in our head, can't we? 10 times 10 is 100. And that's going to be equal to C squared. Add these together and we get that 389 is equal to C squared. Now, please remember now, they didn't say that C is 389. They said that C, whatever C is, when it is squared, is equal to this. Oh. Now you think back to that little discussion we had on a previous problem about this a squared equals b and a is equal to the square root of b. So do you see that what we need to do is we simply need to say that the square root of c squared is c, and therefore the square root of 389 must be c. So we just simply go back to our calculator and say, hey, give me the square root of 389. And I get usually some sort of decimal. I got what, 19.723. Let's see, place them want me to round this thing. Let's just check them out here. What do they want? Thousandth. Here's thousandth. Oh boy. So look, here we go. Tenths, hundredths, thousandths. Okay, so we're okay. 19.723. You see that? 19.723. 19.723 we're looking for. Ready to check it? Nice work. Okay. So the length of, let me go back to my drawing. We had 19.723. Let's go back to our drawing. Let's just go back to the drawing and finish this off. So we had that, the y here was 19.723. These were what, meters? Okay. Does that seem reasonable to you? Think about it. A 17-meter pole would be about 50 feet. 50 feet up. 10 meters out would be about 30 feet. So 50 feet up this way, 30 feet out this way. And this is what, about 60? The length of the 19.73 represents the length of the wire from here to here. So this represents the length of the hypotenuse of that triangle that's formed. And we got it right. I hope that confused you there again. We did get it right.